Hey, welcome to Weld.com, home of TIG Time. Hi, I'm Mr. TIG, and today we're demonstrating how to set up and weld aluminum with this new machine called the MT200 AC/DC, and it's manufactured, or at least owned by CK Worldwide. Just got this in, and I've got some settings that I'm going to test this machine in doing some heavy wall aluminum on this particular segment. When I say heavy wall, I'm going to do an 1/8 inch thick, and I'm going to do it a lap weld. Lap welds are more difficult than being on plate, and you can still see them. So I'm going to go ahead and I've already pre-tacked these parts. Got my torch set up here. It's a CK17 332 diameter tungsten. If you'll notice, the tungsten is pre-ground to a point. Now, there's very few settings needed on this machine. We have what we call the sweet spot in there, and if you just turn the AC amps up to the amperage you need, now I'm going to need about 130, maybe 140 amps, so that's why I've got it set there. Now, the rest of it is going to be almost automatic. I rarely change the machine once I set the dial in the sweet spot. And you'll see the background. There's an arrow, and then there's a little blue area. So I'm on AC. I'm running about 120 hertz. That happens to be in the sweet spot. And as far as the balance is concerned, I'm somewhere in the 70 to 73% negative. Again, that's the sweet spot. So I don't change it. I don't have to. And I just previously welded up some 20 thousandths thick aluminum with the same settings, lower amperage. So just know it's pretty all-purpose, easy to use. So let me get my gear on and demonstrate this, and we'll show you the end results. Okay, now I just finished a weld, 1/8 of an inch thick material. It was overlapped, so it's a type of fillet weld. Anyway, welded up real fine. It started off about 140 amps. By the time I got to the end of the weld, you have to back off because the heat catches up to you. So it was probably in the 120, 125 range. Now, I've added a piece to this now. I just added a 1/4 inch thick plate, and I'm going to do the same thing with the exception the machine settings are the same, the amperage is at the maximum. Okay, so I just want to show that you can do 1/4 inch thick aluminum with this machine, and it does it very nicely. So all settings ready to go. I'm going to flip my hood and get going. Okay, now you remember I had a pointed tungsten, and I did, a couple of welds, each of them 6 inches long. This is how much burn back that I get in my tungsten, and it came back to a very, very small ball. Now, I have this machine set in the sweet spot, that 120 hertz. Now, what that does for you is it chokes the arc down, so where you normally have to have this huge weld in aluminum, it condenses it, so it doesn't challenge the arc as much. It drives into your weld instead of spreads. So just want to show you a couple of examples of how to do heavy wall aluminum. And I received some parts in that a customer, or actually a viewer, was watching us and said, "Hey, can you help me understand how to weld these parts?" He said, "I'm having a difficult time." Anyway, the letter said this was signed Awful Arthur. So Awful Arthur, we received your parts, and he's got 4 parts, and he says, "Oh, hey, by the way, 2 of them are used for setup. Can you make sure you have 2 good ones?" So we're going to try to do that for you. Now, what I've got here is it appears that it's like a washer, and it's magnetic, so it's steel, but it's a threaded type washer, and then it's got like a square tubing going down right on top of it. So pretty thin material, and he says he's having problems having this washer burn out. Well, this is a tough configuration, first of all. So I'm going to show you how I would approach it, and take a look at your machine. Make sure you're using a little smaller tungsten. Go to your 040 tungsten or 1/16 and grind it to a very fine point, because you're going to have to get in there really tight to keep these edges from burning out. So I'm going to set this up on DC negative. And the other thing is, when I'm welding, I'm going to use a gas lens, and you're going to see the footage on that. But also the filler material that you use, you're going to have to drop down to about an 0.35 diameter. If you try to add 1/16, which is so readily available, then you're going to put so much heat to this that the part's going to burn away. So anyway, the secrets are, make sure you got a power supply that drops down to 5 amps very nicely. Also, I've got my gas lens in there, grind the tungsten to a point. What I've got in there right now is I've got the chartreuse colored, it's called laser tungsten by CK Worldwide. Anyway, this is 1/16, ground to a point, and then the steel. The steel, you've got a choice. I'm using some ER80S D2 0.35 diameter just because I have it available. Well, Awful Arthur, this project actually wasn't as easy as it looked, and you probably found that out yourself. So I went ahead and I got 4 good ones for you. I'm going to send them back to you in Arizona. I polished the bottom of them just so you could see that I had a little bit of burn through in a couple of places, but overall it welded up pretty decent. Had a little bit of gap there. Of course, the more gap you can eliminate, the better off you're going to be. But mild steel, most of the time I started my arc at about 5 amps, just crept up and created a puddle and then tacked. So that's very tricky. But no, but welded just fine. We're going to talk about structural steel welding. And when I talk about structural, I'm talking about things like 1/4 inch thick, pipeline that's a 1/2 inch, 3/8 inch thick. Now, we're not going to penetrate with one pass with TIG welding. So what I want to do is I want to show you that the root pass is so critical to all the structural welding. So what you're going to find is that you put in a root pass with TIG welding, and then you can fill it up. You can fill it up with stick welding or MIG or flux core, one of those other processes. But it doesn't take a lot of heat to put the root pass in. So how important, and really what is the root pass? I want to show you in this little T-joint right here where it was welded on one side with the MIG welding process. And then it was cross-sectioned, and you could see the penetration or lack of. That really is what the issue is when you're dealing with the MIG welding process. Can you always get adequate penetration? With TIG welding, you can assure that you're going to get down to what we call the triple point. And that is right down here where it looks like a crack. You just got to get penetration. It's not going to require a lot of amps, but I'm going to do that as a sample right here just to show you that I can do this with 125 amps. I put the root pass in, and then you can take your other welding process and fill it up and make it as large as you want. Now, once I do that, I've consumed about 75% of the strength of that joint. 75%. Now, I can put this huge weld on here, but if I didn't penetrate, then it's going to fail. Somewhere along the way, it's going to fail. So let me show you how I put a root pass in. It's low amps, it's a very close arc, and it only takes about 125 amps. So let me get my gear on, and we'll get started. Okay, I've got my MT200. It's an AC/DC machine. I've got it set on DC right now. I've got a 1/16 diameter tungsten ground to a point. Of course, I've got my gas lens. I'm running at about 15 CFH of argon. Now, over on the panel, I have the maximum amperage somewhere around 125 amps. And that's all I'm going to need for a root pass. So it's just amazing how important that root pass is. Now, you can do a couple of things. You can do your root pass, and then if you want to continue to fill this out with TIG, you can do that. Once you get the root pass in, you can go ahead and go to a little larger diameter filler. This is only 0.45 diameter, but all I'm trying to do is get down in that root and get that done, and then I'll jump up one size, maybe two sizes, and do a second pass, and then I'll make a nice fillet weld. When you do that, you're going to have to increase your amperage. So the root pass will be at 125 amps, and if you want to fill it, then just increase it. You may need 175, maybe even go the full 200. But this will do just about any structural steel that you want. Okay, so we've got the root pass in there. 1/16 tungsten, not a problem. Didn't even challenge the machine. I can practically go all day long doing this. Anyway, thanks for watching TIG Time. I'm Mr. TIG.